Good afternoon, everybody. You all had lunch? Everyone's feeling good today? This is Discovery Track, and this is a discovery session. My intent today is to talk about low latency streaming, what we at Wowza have discovered as far as what several firms, particularly many of our customers, are doing, what they want with low latency. And I'm going to show you a couple things at a real basic level. Recently, I had this aha moment. I've been in video streaming for many years. I've been working with video servers, particularly at Wowza, for a long time. And I've never actually seen a chunk file show up on a computer, like literally show up. So I wish somebody would have shown me that in the beginning. So my intent here is just kind of from a baseline. This is not a CTO level discussion, just talk about low latency today. And I'd love to answer some of your questions at the end. So thanks for joining us. Today we are talking about latency. Latency is, let's speak to the obvious here, the amount of time from when a frame of video goes through the lens, hits the sensor, gets into the camera, pushed down through an encoder, into a media server. I have a diagram I'll talk about in a minute. We call it glass to glass, essentially. There's glass on your device, glass on your monitor. That's the amount of time we're talking about to deliver that video. And a typical live streaming workflow, you can see we start with a camera, it gets into an encoder, and then we process it in a media server. So that's where the data comes in, typically via RTMP, maybe SRT. We'll talk a little bit about protocols today. But it gets processed and packaged, then pushed out into a CDN in most cases, and distributed for playback. So there are a lot of steps in the process of distributing video. Looking at it from the left to the right is a frequent way to describe it. It's very linear. Now, this particular conventional video streaming workflow, glass to glass, out of the box, about 30 seconds. It's a nice, stable, reliable, LLHLS, MPEG dash type of stream. Now, we also do this with low latency, and it looks a lot the same, doesn't it? Goes from the camera, gets encoded, but there's a lot more going on at the ingest and packaging level and the distribution. So it's the same thing, but we're kind of cheating a little bit, particularly when it comes to HTTP distribution. We can shorten the chunks, is one way to do it. We take it from a 10-second chunk length to maybe 1 second or 2 seconds. So we can get the latency down today, but it's kind of cheating. And that's okay, a lot of us are doing it, and I'll show you some statistics. But I want to talk about low latency. Now, I like to use memes because this is how I feel about a lot of technologies. How many of you remember 3D television? Yes. Of course you remember 360 VR. There's these new technologies that come out frequently. I've had people tell me they need a certain technology because they want it. You know, I've been on working with clients and they'll say, I got to have 12 megabits per second, 1080p. I have to have it. And it's almost an unchallengeable position. And you know, that in many cases, 12 megabits is too much for 1080p. It's extreme. And sometimes people get into these new shiny aspects of technology. Low latency is one of those things where we need to know if you need it. Do you need low latency? Because there's people that have that attitude, and that's, pardon the levity, but they're like, I need low latency streaming. Why? Why do you need it? Well, there are justified reasons. And then there's situations where I would comfortably say, you don't need this. Your use case doesn't demand it. It's not horribly required. So when I talk about low latency, I'm talking about it being a resource that enables an actual use case. So Wowza did take some time. We got in touch with people in the industry, some of our customers, and we did what we're calling, and you can see it right there, a video streaming latency report. We talked to 391 broadcasters. Doesn't look like that many. It's a lot. And we asked them a ton of questions. And so we got into some really interesting topics. And we realized, first off, that so much of this is about interactivity. And you can see that we broke it down here. Live sports is certainly number one. I mean, who wants to be in their apartment or watching a game on broadcast and they hear it, hear people cheering down the hall who may have been watching it on a lower latency service. Or maybe you're watching it on Twitter and the people on broadcast are hearing it first. Nobody wants that. They want to hear it first. Esports, I could easily segue on esports because this guy went to TwitchCon. This guy shouldn't have gone to TwitchCon, but I learned a lot. I will keep going. Video and audio chat, gambling. Gambling is really a fascinating part of the streaming business. A lot of it, if not all of it, is overseas. Auctioning, interactive applications, OTT. You can see that there's some pretty, as expected, verticals for low latency and interactive use cases. But the one I'm driving toward is the gray bar on the bottom, which is other. This is where it gets kind of fun, because you can kind of get in touch with some of these use cases. This is where people who are starting video companies or creating applications, they want that interactivity. I'm working with a company right now that does live meditation, which is somewhat of a unique use case, but they need that interactivity. Healthcare. I'm working with another case right now where a company is actually learning how to monitor premature babies that are in a clinic in a in areas of the world where there aren't doctors. They need that instant, if the baby moves, they need to see it right now. I won't go through every one of these. I thought weddings was interesting though. It's like, who needs low latency for weddings? Remember earlier when I was shaking it down, like, do you really need low latency for a wedding? I guess some people do. Surveillance, obviously, drones. I sure hope we have low latency with drones, especially those who do it for EMS and surveillance and such, because you have got to know what you're doing there. So as you can see, there's just several kind of cool niche areas where you can apply low latency. Now, this is one of my favorites, okay? I was working with, and I want to emphasize the accessibility of the technology. I was working with these cowboys from Alberta, Canada. Literally cowboys. They sell cows. And they were trying to save people from having to drive 200 kilometers to this auction. And so these non-technical ranchers got a hold of a streaming server. We were able to tweak it for low latency, and they're gaining that efficiency. So it's fun, and it's no bull. Honestly, that's a cheap one, but no bull in that story. So the takeaway from that is these unique use cases. We saw the list. It could be something as fun as a cattle auction. There are genuine applications for low latency streaming. So I really enjoy how broadly it can be applied. Here is a chart that illustrates kind of the spectrum of latency. Earlier I was talking about the comfort of having a stable, standard spec HTTP stream. That's over on this side of the slide where it says 45 seconds. If you go today to pretty much any streaming service, you're probably going to be anywhere from 30 to 45 seconds. That's great. But maybe you want to reduce that. So reduced latency would be 18 to 5 seconds. And by the way, 5 seconds is about what cable TV is running. And then there's low latency where you're getting into faster, maybe 2 to 3 seconds. Maybe, it varies, maybe, 3 to 5 seconds. But you're getting a nice kind of middle ground between reduced latency, and then there's near real time, which is on the cutting edge. So I'm getting excited here because I want to show you a couple things. I'm going to do a live demo. There's somebody in this room who actually wanted to stay for my live demo because they like to watch people suffer through live demos. And my screen just completely went nuts, which is not good. So you'll have to pardon me. I've got a dead stick here. This is great. Okay. So here I am. Wow. Hard down. I got my mouse back. Wow. Okay, so for sake of sanity, I'm going to skip the demo. But I can't see my screen, so here we go. All right, so apologize for that, by the way. That sucked. What I was going to show you in the demo was this. When you generate a file with a streaming server, you're generating what's called a chunk. A chunk is a file. It's a TS file. If you double-click it on your desktop, it'll pop open in QuickTime Player or VLC, and you can see that a chunk file runs for 10 seconds. Great. When we reduce the chunk size, those same files show up, but they can be like 1 second long. So when you're watching a video on your phone, you're watching 1 second, 1 second, 1 second, 1 second, 1 second, 1 second, all smoothly being played back to back. I was simply going to demonstrate that. I was also going to show you 4 screens. There was regular HLS, RTMP, which is flash. I was going to show you tuned HLS, which is the short 1 second bursts. And I was actually going to show you CMAF and WebRTC. If you're legitimately interested in that, find me. I'll show you when I'm not stressed out and my display isn't all over the board. So let me blow through this report, and then we'll get into a couple questions. First of all, what's the most important factor for low latency? First, they want high quality video. You can't sacrifice quality anymore for low latency. You can't say, well, it's really fast, but it's pixelated. Viewers don't appreciate high quality video. They simply expect it. Ability to scale, obviously. If you're scaling using a proprietary protocol, if you're using Wowza streaming engine, for example, and you're not using a CDN, you're going to have to buy a whole lot of instances of software, which is very costly. That's a good way to go. Happy to sell you the software. But it needs to be able to scale. Low end-to-end latency, we've covered that. Real-time interactivity. How are they currently doing it today? Most people are doing it by cheating. I like to call it cheating, but I say that objectively, watching those quick 1 second segments. That's how most people are doing it today. There's also real-time protocols. People are still using RTMP. People are still using RTSP, which is super fast. It's not chunk-based. It's just straight, good old-fashioned streaming. I talked to a guy today who used to work for Real Networks. Anybody remember that? Download Real Player. Those same technologies are still alive. I'm kind of proud of that. Okay, and then they're using, there are proprietary solutions. Videon has a really cool one that uses Amazon S3. I've never had the time to actually check it out. Wowza has a proprietary, it uses WebSockets. We can get video in the browser delivered very fast. There's a handful of them out there. And then there's other. How do they plan to reduce it in the future? 12% of the people are still going to do that short segment duration, which is a viable option. People will still use their RTMP. Good luck in 2020 using RTMP. Maybe you can backdate the phone, the date on your computer. I don't know, maybe there's a way to cheat it. But what I'm saying is RTMP is flash. It requires a flash plugin, and the major browser platforms, particularly Chrome, are saying no more flash. HTTP, low latency, which is essentially the low latency HLS, and that's something I haven't even mentioned until this very moment. Apple has taken and released a spec that can take that chunk, that 10-second chunk, and then break it down into little segments. And we're working on that. I think we're going to be one of the first people to get it marketed, or get it out to market on a streaming server. That's where you get, the player can actually get little tiny segments of a chunk. It's fascinating technology. It's very new, and I believe that's where this is all going to end up. When that product matures, low latency HLS, we're going to all be using it. We ought to, because it's universal, plays on the devices, plays in the browser. We don't have playing in the browser quite yet, but we're getting there. And then there's also still going to be the very valid, very useful proprietary solutions. And then what can you do now? Again, what can you do today if you need ultra low latency? We're right on the cusp of low latency HLS becoming completely available. Today, WebRTC, people are using it like crazy. 3-4 years ago, if someone asked about WebRTC, it literally was kind of a joke, right? Now it's being used extensively. That use case I mentioned earlier where doctors are saving babies by watching them over the internet in another continent, they're watching it via WebRTC because of low latency. SRT, which is one of the most, I think, groundbreaking developments in the last couple of years, that's where you get a resilient stream, where it uses UDP and it can go back and get packets that it lost. I think that's a good solution. Playback on that is still a little bit of a science project, but it's possible. Apple low latency HLS, which is what we just mentioned. Low latency CMAF for Dash. I like CMAF. It just feels right. You guys, have any of you heard of CMAF? Common Media Application Format. I thought that was going to be the salvation, and Apple kind of showed up and said, just like true to form, Apple does this. We're all doing low latency HLS. And then, of course, proprietary solutions will always exist. And I had to use one more meme. Low latency HLS is coming. Yeah, but I have WebRTC. So that's my presentation. Do you have any questions?
Do they ever? They want to know where you got those awesome memes. Who's got questions, people? Come on, put together memes for you.
Sir.
How How will 5G affect latency?
How
it
will
says.
5G affect latency? Yes, they are. I'm going to answer it with my opinion. What's your internet speed at home? 300? 500? Anybody have 1 gig at home? Did it help your Netflix? Thanks, Nick. Did it help your Netflix? Not really, right? I think it's all about reliability. If the 5G networks are faster, ping time, jitter, those type of dynamics on the network, that player is going to get its data faster, and ultimately, I think it's going to help. But I don't think it's going to change the world, honestly. That's just my opinion.
Okay, another question? If you don't have one, Nick has to ask one.
Yes, sir. Oh, go ahead, Nick. Sorry, you'll be next.
Why do you discount CMF so much? There are so many shops that are using Equidash.
If it sounds like if you got the impression that I was discounting CMAF, I gave you the wrong impression. I think CMAF is fantastic. I like that it uses MP4.
I'm not talking about the technology.
Okay.
The impression was the domain-wise Apple will take over the scene.
I have a pessimistic is the wrong word, but it's been my observation that when Apple says this is the way it is, because they own the iPhone market, because that is the majority for that hardware platform, that things tend to go that way. But I in no way would, in fact, it would be opposite. I personally like CMAF better than low latency HLS, because CMAF, it seems like the spec has been matured, people have been working on it, you can go and look at it, whereas Apple, it's still kind of, really, really cutting edge. I don't know if I answered your question or not, but thank you.
He is not putting down CMAF. He adores it.
Adore it, indeed.
But Apple, you can't fight it.
Hey, I guarantee most of you in this room have an Apple product in your pocket versus an Android, and let's not start that discussion. Nick, did you have a question?
Of course he did.
I'm just wondering if you offer, like Wowza offers professional services to help with a lot of the complex streaming solutions that, get propped up. Is there a way that someone could come and have some help from Wowza to get all this stuff up and running?
As a matter of fact, Wowza does provide
What?
experts, people that are smarter than me, to do just
I
exactly
thought it would be
that.
no. I thought you'd just say no.
No.
So yes, we do have a professional service, because everything I'm mentioning, the cheating, I call it cheating, short chunk duration, there are dynamics with keyframe interval, and there are dynamics with chunks. There's a lot of properties that need to be addressed, and a lot of tuning and a lot of testing when you're going to go short chunk duration. So, at Wowza, if you want to get beyond a technical support experience and actually deal with somebody who knows what they're talking about, we've got that option for you. Thank you.
Just look for someone in a bright orange shirt. And
They can direct traffic and help you with your media server. Yes.
Okay, anybody? Oh, we got another one.
Yes.
Good.
Yeah, how low you think the latency will go to?
How low?
Yeah, I mean, at which point that become irrelevant? At the 0.1 second, 0.2, or half second?
Don't you think that the laws of physics, we're going to run up against a wall when it comes to just how low can it go? It can't go lower than lower than 0, and we're already in the half-second range. WebRTC is near real time. I mean, if you use Zoom or GoToMeeting, those type of technologies, they're using a WebRTC type of transmission, and it's just like being on the phone. So I would consider that sub 1 second. I don't know if I would in a general capacity get less than a second. I just don't think it's.
From user's experience point, how
I think personally, I think sub 1 second is adequate, because it already is working for the mainstream use cases. If you've got some kind of military spec, some type of niche requirement, then you can get in some different technologies and really, really batten that down. But for mass distribution, I can't imagine sub 1 second making sense.
So, round of applause for Tim, please.
Sorry about the display. I'm bummed, but you guys were awesome.
Thanks everybody for having me. I'm Elsa Pine. I'm with EdgeConnects. I'm the VP of Sales and Marketing, and we help bring all the video quality right to the edge of the users. I think, is there anybody from Comcast in the room at all? So, just recent announcement that Comcast has about 85% of the eyeballs in the US. 17 of their 25 platforms are in our data centers that we built for them over the last 5 years. We've also added that for Cox, Charter, a few others. They built them to reach the end users at the edge. All of us who are using the video on our phones, tablets, wherever, but mostly from your home. So what has transpired is a need to re-architect the internet. Many of your gaming providers, say it's Disney Plus, say it's a few others, all of them need to move to the edge to be closer to the eyeballs so that they can have a better performance for the end users. Everybody's been talking about latency before and throughout this entire conference, but it's also jitters. I think jitters is a very important concept that is overlooked. And if anybody's got any children that are playing Fortnite, they'll be the first ones to tell you exactly what their speeds are because they know how to go in and see where their servers are coming from. And my 12-year-old can actually go in and reprogram this. My 18 and 22-year-old could not. So your younger generation have a lower threshold for performance. So the performance has to be that good or they will not be able to win in their games. So that's just one example of how we've been seeing the changes happen. A lot of your gaming providers like Twitch, the Google Stadia environment, NVIDIA, all of them have built these high performance compute platforms that are roughly 30 kW per cabinet. So we're the largest privately held REIT that went out to build the 4th generation of data centers. So I came from the world of Equinix, CoreSite, where everything was built like the 4 to 6 kW per cabinet range in density. Now everything is a minimum 12, 18, 24, 30. Some are pushing 50. Some of that does require some containment in these data center environments, but that much video and the GPU processing, which is all graphics, is requiring a lot of power. So not just the power needs, but also the connectivity to the eyeballs. So Comcast will provide private peering right out of our site so that you get right to their CRAN. There's usually a minimum requirement for you to get 100 gig connection to them, but we're seeing that happen a lot more often. I'm sure everybody's seen these slides about what happens every 60 seconds, but quite frankly, we're just not ready for it. And Akamai is one of our biggest customers. They too are expanding every single site to support Comcast, support Cox, support Charter, because all of their end users, even if they're flipping the switch and getting off cable or turning off they're not turning off their internet. So the streaming quality's still got to be there. Again, 66% of us are watching everything on a smartphone, and that's pretty alarming. I know my son who downloaded the Disney video app, well, everyone did. I think he's watched like a movie every single day. And he's watching it on his phone. He's not watching it on any TV or any, and they're doing a great job promoting to each user in their genre as well as in their age bracket to know which ones to play next. So Google Stadia platform is a little bit of a top secret when they first launched, because it was just really a test. But they're in about 12 of our data centers. We've got about 40 right now globally, but Google's platform is performing pretty well. And this was just a test. So they're about to launch even bigger than what you've seen in NVIDIA, Twitch, and a few others. So again, we've talked about latency and jitter, but it all comes down to physics, economics, and the law of the land. And quite frankly, there's a land grab right now for data centers to be able to be close enough to the eyeballs, and Comcast, Cox, and Charter are not going to pick up and move where their gear is. So how big can we build these facilities to support what's going to come next, or how much more they're going to need? And it all comes down to storage. It all comes down to the compute, but it is becoming rapidly a big necessity to have private peering with these providers to support the quality that the end users are expect. We haven't even gotten into autonomous vehicle, but we've got one we just put an announcement out yesterday. One of my clients is doing a test for one of the large vehicle manufacturers in Detroit. So they put their gear in our Detroit site, and it's going to be a localized test with a wireless provider. But it's not just what's happening in the car. The car, like there's sensors and stuff is staying in the sensors. It's when they do the downloads, and literally people are bringing tapes back and putting them back into a server to capture all the data that is being delivered. And for every sensor of, let's just say your signaling, there's a double. So they want to make sure that everything is going to happen correctly. So if there's an accident, they can see what caused the accident on the other double. So for every one, there's a double. Sometimes there's a triple, depending on the application. I think in healthcare, you're going to see a lot of the triple needs. But we're seeing a big need to localize this for autonomous vehicles, and I think you're seeing tests in some cities where it's flat. Like you'll see that happen a lot in Phoenix. We've seen a couple of them happen there. But now Detroit's the first one that we're deploying out of our site. So again, proximity matters, milliseconds count. There's a general rule of how many miles a gaming platform needs to cover. So it's roughly about 1,000, but I heard it's 900 miles. So if they pick up, for instance, a market like Jacksonville, Florida, that radius of 900 miles will be able to support out of our Jacksonville site. And then they'll move down to Miami. Some of these highly dense suburban areas, though, need to move closer. So you'll see Disney expand. They just launched. They did a really good job launching, but I don't think they estimated how huge this was going to be. I mean, they got 8 million customers for free from Verizon. So first year, anybody that's got unlimited data gets Disney Plus for free. So I don't think they expected that, but they're going to build it out as they see the test go in some of these markets. But as you can see at the localized side, the Edge Connects, like for instance Atlanta, I've got a lot of customers in the gaming world that are there, and I'll have some of the texts come in and be like, oh my God, this is why my ping is so fast, because they're right here. You know, Twitch, NVIDIA, Google, you name it. But the eyeballs are important, but also the delivery of that for the eyeballs. So the Akamai's, Limelights, Fastly's, all of them have to support the Comcast, Cox, and Charter networks as well. And they can't keep up. Right now, that's a big problem. So again, we're bringing it closer to the gamers. Of all of our data centers, we cover 50 of the top cities of gaming. And that's really just suburban markets, if you think about it. And here's a little preview of where all of our facilities are. We are adding quite a few. We just added Santiago. And Buenos Aires is open. South America is booming. We can't keep up with the demand there. I'd say the US is at a tipping point right now for a lot of this data. And we're at the forefront because we built a lot of these sites to the high density. Anything that's new gear coming in is requiring massive amounts of power. And unless you have this cooling to support that, it's going to be a really costly item if you don't think carefully about it and where you're going to put it. But I've got plenty of maps and plenty of charts that show who's where in each of our sites, and I show also the content providers that are in those sites. So if you connect to them or if you're a partner with them, sometimes moving away from where what I call the main peering hubs are, they're changing this. They're already changing subsea landing stations to be able to support, Facebook, Google, and a couple other, like they're creating their own private landing stations just for connectivity. So what we know now is the main peering locations are all going to change because of these new subsea landing stations that are being added. But across all of our platform, we have availability for a single cabinet to come into our data center, but we also, our biggest claim to fame is doing build to suit. So large cloud provider out of the West Coast says to us, we need a data center, 40 megawatts in Dublin. How quickly can you build it? And we did it in under 10 months. And that's in another country, needing all the permits, et cetera. And for every day, if we weren't there on time, it was $1 million charge to us. And we came in a month early. So we built a lot of build to suit. So these large cloud providers build their platforms. They ask their partners to come closer to them so they can just have a private connection versus using the internet and using, obviously, the telecom needs that cost a little bit extra. So here's a little bit of our glance, but again, happy to share we have our own homegrown monitoring system that is widely used, single pane of glass, looking into every one of our data centers, tells you a heat map, gives you humidity, gives you how it's performing. So versus going in separately, you can see everything, and everybody's got a different need in each position of their company. But we've done a really good job of keeping this in-house, and a lot of our customers want us to white label it and send it off to other providers, but we're keeping it. So average build time is usually 6 to 9 months, and we'll build a data center wherever anybody needs it. So there's a lot that goes into figuring that out in the fiber paths, et cetera. But we've got a really great team of experts in-house, and for a private company, we're only about 150, and we're the top supplier for 5 of the world's largest customers that consume data center needs. So again, it just shows you everything from the micro edge, which is still in its infancy a little bit, but we just deployed the first one with Detroit, so we'll see how that goes. But again, these can be a container, it could be a single cabinet in a metro office in cell towers, but we have access to all of them and the rights to all these buildings. And that's it. Any questions?
Oh, who's got a good question? I told you she got special prizes. Is this on?
Yes.
Special prizes. All right, hold on. I got a mic. We want to get you on the video. Is that you in the blue? You got the question? All right, Joe.
So I'm just curious, how did you guys identify the locations that you needed to be in so that you could better support the streamers and that supply chain when you were going out and building your first, 30 data centers?
That's an excellent question. I really do think a lot of this has been about luck, and we were right there. Comcast came to us and said, we need 25 data centers built. How quick can you do it? Well, we built one in 3 months in Boston. They were gonna either build it themselves or have someone build it for them. We did half the cost as well as half the time, and they were in those fiber markets. They are the ones that chose that. So because the eyeballs, they knew where they wanted to be, and they knew where the fiber was. And we would just pick out, we have a couple of locations, which one do you want? And our average size used to be about 2 to 4 megawatts. Now we're building 10, 20 at a minimum. Each anchor is about a megawatt minimum. So we're with them side by side, looking at all these locations, taking them out to go see the properties. Some are greenfields, some are brownfields, but we own most of our real estate. I think there's only like 1 or 2 that we lease, but that's it. So before we're out of the gates opened with that anchor client that's there, we're already even a profitable.
So it's really your client's performance tools and data that was driving the locations, and you were building to suit for them, or
Correct.
trying to suit
Right.
them.
Where the customer needs it is where we're going to build it. We're not going to say, oh, we think it should go here. You should just come here. No. Let's disperse them properly, and they might be adding a couple more, because as the areas become more concentrated, especially in suburban markets, there's some bigger issues going on, and they're feeling them, that even their suppliers are building to support them at a very, very fast rate right now.
Also, I heard you say that was an excellent question.
Yes.
Joe gets socks, blue socks, match your shirt.
Sorry.
All right.
I gave you the blue because they match your
Oh,
shirt.
now we got some questions. All right, hold on. Winston, is it? All right, make it good.
So how do you decide in terms of hardware gear? How do you decide 100G or 400G networking hardware? How do you decide to be able to? I think this is more like private cloud. How do you supplement with the public cloud? Let's say Facebook or others.
Oh.
How do you decide what criteria do you use so that your technology will be there for many years later?
Absolutely, great question.
Great question.
So there's hybrid, public, and everybody has their own origin environments. We have built, I don't know how many markets. We've got Megaport, Packet Fabric in, so there's SDN markets as well. We've got Amazon's Direct Connect in Portland. They're adding in, I think, 10 other sites I can't disclose yet. And Facebook, Netflix, all the rest of them, they will put their gear right next to that content provider, or the eyeball network that they're trying to reach. So rather than have the networks go back and forth with the content, Netflix drops a 10 cab solution right next to every Cox, Charter, Comcast environment. That's how they're all doing it now. They're just copying the Netflix model because it worked, and it was the only way. You know, when they first launched, remember level 3 was like dropping everybody else because they were trying to push all this data, the video across, and no one provider could ever support it. So now they all just move the data, their content, as close to the edge where the eyeballs are. It's mostly for consumer use. The enterprise side, for the Microsofts and the Google clouds and Oracle clouds, they're doing it differently. They're our customer. We are not selectively going out to an enterprise and saying, oh, come to our data center. We're gonna send them to somebody else because we service the wholesale market. So you really have to know how to operate with your power, know how to use your loads efficiently. And some of our sites are lights out. Like Comcast did not want anyone in the site. So wherever Amazon, Microsoft wanted, we had to move to 24/7 security, so we had to change that model a little bit. And where it supports more use or remote hands, we're gonna build it out. But they're all there. But a lot of them are using private connections. They're not using. We've got some of the networks in our sites, but not all of them. We're not Equinix. We don't charge $325 for a cross connect. It's only $100. But if you're a content provider, you don't pay for them. So.
Okay, and that was an excellent question?
Yes.
All right, who's got another excellent question?
There you go.
I saw another hand over here. All right, sir, here you are.
Is cooling a significant factor in the data centers, and is it more expensive to build one of these in Vegas or Phoenix than it would be in Seattle or Boston to operate them anyway?
Good question. Yeah, obviously there's cooling efficiencies in a colder climate that we can use outdoor chilling and a little bit more greener effects. We're still using a lot of power. Cooling is the biggest factor of all. So our density is 300 pounds per square foot. Your average data center is about 100, 150. So we built these to really support, the hot out, cold out. We'll do containment. We do chimney containment onto some of these cabinets. We've had to for when they're going up to 50 kW per cabinet. So, but we manage pretty well. Most of our data centers are about 1.3 on a power usage equivalency. So you're trying to get as low as possible to keep the cost down. So 1.2 is optimal, but until the data center is full, you'll never get to 1.2, right? So there's always capacity for growth, and for some of these customers who they've pretty much taken a ROFR of, you know, doubling or tripling their space over the next 5 years.
Okay, and that was also a good question I heard.
Yes.